Hello everyone, I'm Pallavi. I'm from third sem B section and my teammate is Nidhi Joshi. Today I'm going to discuss about the subject that is data structures and applications, and the topic is queues and dynamic data. It is very essential for all of us to know about what is queue. A queue is a linear data structures that follow first in, first out, that is FIFO principle. The meaning is the element that is inserted first will be removed first. It is widely used in programming for tasks such as managing process, buffering data, and performing breadth first searches. In traditional implementations, a queue can be represented using arrays or linked lists. However, when the size of the queue is unknown or changes dynamically, dynamic arrays offer a flexible and efficient solution. Unlike static arrays, dynamic arrays automatically adjust their size when more elements are added on, optimizing memory usage. Here, uh, first initialization of the queue is done. That is, initial queue is given here, and the insertion from the rear end is done here, and deletion from the front end is done here. Next, moving on to the dynamic array implementation. Dynamic array is also known as growable arrays, can dynamically resize themselves when they are full or when elements are removed. Here's the breakdown of the implementation. First one is initialization, second one is enqueue operation, and third one is dequeue operation, and third one is resizing down. The first operation, the insertion of operation in queue, that is enqueue operation, and that too using dynamic arrays. First one, check capacity. We should check capacity of the queue before we should add or delete. So before adding a new element, ensure that the dynamic array has sufficient space. If the array is full, it indicates that the current capacity cannot accommodate more elements. Resize if full. If the dynamic array is full, a new array with double the current capacity is created. The existing elements are then copied to the new array, preserving the order. This resizing operation ensures that the queue can accommodate the new element and any future elements. Next is add element. The new element is inserted at the rear of the queue, and the rear pointer or the index is updated to reflect the addition of the new element. The resize of the queue is incremented to account for the new element. Next, here the representation of the initial queue is given. The initial queue is given. Here the front is pointing to 1 and rear is pointing to 4. And after the adding the element 10 to the queue, that is enqueue operation, the queue is 1, 2, 3, 4, and 10. And now the front will be pointing towards 1 and the rear will point towards 10. Next, the DQ operation and further operations are explained by my teammate Nidhi. Thank you.
Operation is DQ. What is DQ? A DQ is a linear data structure that allows insertion and deletion of elements from both the ends. There are two types: input restricted DQ and output restricted DQ. Input restricted DQ. Insertion is allowed only at one end while deletion is allowed at both the ends. Output restricted DQ. Deletion is allowed at one end while insertion is allowed at both the ends. Key operations of DQs are insertion, deletion, and other operations like is empty, is full, get front, get rear. Knowing insertion, we use at the front, insert front, at the rear, insert rear. Deletion is also the same type from the front and from the rear. Later we have the other operations is empty. It checks whether the DQ is empty or not. Is full checks the DQ is full. Get front gets the element from the front, and get rear gets the rear element. There are implementation based on array and linked list. Array based uses a circular array to optimize space, requires managing front and rear pointers, whereas linked list based uses doubly linked nodes, offers dynamic size and efficient insertion and deletion. The applications are palindrome checkers, compares characters from both the ends, sliding window problems, scheduling and task management, window operations. Advantages are they are flexible for insertion and deletion, useful for both FIFO and LIFO operation. The only disadvantage is they are slightly more complex implementation than standard queues or stacks. Dynamic features of dynamic array queues. A dynamic array queue is a queue that resizes automatically as elements are added or removed. The key features are dynamic resizing, circular implementation, efficient operations, flexible size, memory optimization. Dynamic resizing adjusts size automatically to accommodate more elements or save memory. Circular implementation uses front or rear pointers to manage elements efficiently without shifting data. Efficient operations supports the NQ and DQ with average time except during resizing. Flexible size, no predefined maximum capacity, grows and shrinks as needed. Memory optimization reduces the memory wastage compared to the fixed size queues. The only application is task scheduling, buffering, and dynamic resource management. Conclusion is dynamic array queues are efficient and adaptable, ideal for scenarios and unpredictable input sizes. Thank you.